And we're back, and it's the Q&A questions for the month. All right, let's get into it. So the first question is from VHS90, and they ask, I love the project, but World War III worries me. I hope all efforts don't go in vain. Please speed up TAO development, and realistically, can we expect a testnet and demo by 2026 or 2027? Kareem.
Thank you, VHS90, for that question. I think the timeframes that you mentioned are very realistic. We're putting the final touches on Testnet Alpha, which is a very preliminary versions of Testnet. And Tau itself is making very good progress. So the timeframes that you mentioned are very realistic, I think. Thanks again for the question.
All right, fantastic. Thank you, Kareem. And the next question is from Learn Tao. Welcome back. And he asks, is Professor Franconi currently working on Tao's KRR, or will he wait for the testnet release to begin? What is the relationship between KRR and the Tao language? Over to your head.
Yes, so Professor Franconi works with me all the time about KRR aspects. And there are several such, which also touches the other question, what is the relation between KRR languages and the Tau language? Well, so at the most basic level, the Tau language is a language extension mechanism, so it can extend virtually any language, including KRR languages. And to this end, we need a good support for KRR languages, and something that turns out to be not easy to find because the good KRR implementations were basically abandoned many years ago. And moreover, at this basic level of extending KRR languages with the Tau extensions will give only extremely limited connection between the software specification layer and the KRR layer. So to this end, there is also an effort to extend the Tau language itself with KRR abilities, and then there is much more connection between the software specification language and the general knowledge, the KRR aspect. And another ongoing aspect that we work on is, like I said before, KRR implementations are good KRR implementations are pretty much abandoned. So we try to see whether we can use the Tau engine to support KRR languages. We know from complexity perspective that it must be possible, but we still didn't find a way how to do it, but we keep thinking about it. So I guess that's a good taste of the research with the Professor Franconi regarding KRR.
All right, excellent. Thanks, Ahad. And the next question is from Philip, and he asks, will the testnet be ready by 2030? The workload seems overwhelming for just a few developers working on such monumental tasks. And is the budget sufficient to hire more developers?
That's a great question. Actually, our strategy is structured to manage exactly this kind of complexity efficiently. As you see, this year our main goal is to release a testnet alpha. And this approach allows us to test the core logic and the economic model in a live environment. And on the other hand, it will allow the community to have a live hands-on experience on the working network. And the foundational pillars for the testnet alpha actually already in place. We have a core engine running, we have blocks storing, and we have a reliable chain state in place and ready for action, and you will be able to experience it soon. As for the next year, we plan to deliver a production-ready testnet that having all the core concept validated and core logic, core engine, and the whole approach validated, we will re-implement it in a production-ready manner with the efficiency and the scale suitable for the large blockchain network. So 2030 isn't even on a radar. We have clear, achievable milestones, and you can visit our website and see how the team is steadily moving by the roadmap there. So we're on track. Thanks for your question.
All right, thanks, Andre. And yeah, Philip, to answer your question around the budget, yep. So we absolutely will get the project out. There's nothing stopping us with the budget we have. However, funds would also make our lives a lot easier, as with most projects. And yeah, we are looking to bring on another engineer to work on the Tau language as we speak. And the next question is from Learn Tau. And he asks, do bit vectors indicate the size of a table? Where columns represent input conditions, rows represent different combinations of those conditions, and each row maps to an output.
Thank you for your question, LearnTown. Bit vector are just an array of bits, and as such, they can be used to encode whatever information suites in them. In general, tables can be encoded using a function from 1 to 2 to the n into a given Boolean algebra B, for example, where n is the bit size of the keys and B is any supported Boolean algebra in the Tau language. Another more interesting case is when we encode the tables using a function from the set from 1 to 2 to the 2 to n into B, being B as before Boolean algebra. In that case, we could represent the elements of the table as simple Boolean functions over B in n variables. So this kind of encoding of a table allows you to have multiple rows, because you could consider product Boolean algebras, or you could consider also sets, represent sets of tuples. So the idea of a table is something different from the idea of a bit vector. Thanks.
All right, fantastic. Thank you, David. That was extremely insightful. And I'll ask the next question, which is from Dana. And he asks, can the Tau language support easy export to DIMACS CNF for backwards compatibility with mainstream solvers? This could attract more mainstream developers. Over to you, Ad.
No, the DIMACS format is far too basic to support the complexity of the Tau language.
All right, fantastic. Thanks, Ahab. And the last question again is from Dana, and he asks, Tau language needs a built-in tool to help developers avoid state explosion. Perhaps something that tracks clauses prior to passing. This would likely attract more developers.
Thank you for the question. This process of avoiding state explosion is actually very complex. And for example, the suggested clause size or something like that is not sufficient to really give an estimate on how many states running a formula will require. So there's actually just two options in general to avoid state explosions. The one is to make a language such that these explosions just don't happen, but this would imply that you restrict yourself to subsets or sub-languages basically that are suffering a lot in expressivity. So for example, the Tau language as it is now wouldn't be expressible. And the other approach is that you yourself have to judge the formula on how execution will look like. So this is not something a tool can reliably do for you. This is much too intricate. However, there might be heuristics, but these heuristics will be more complex than, for example, so they would require some sophisticated ideas on how we can bound the complexity of a single formula. That is not something that has a priority as of now. For now, I think the best thing you can do is to think about how complex the formula is, basically. Does it have a lot of redundant information? Does it require does it require a large look back so that the fixed point computations and the satisfiability algorithms will need longer? These kind of things are what will cause state explosion, aside from basic formulations in CNF or DNF. But yeah, this is not something that is reliably answerable by some kind of tool.
All right, fantastic. Thank you so much, Luca. And thanks to you guys for asking such great questions. That's VHS 90, Learn Tao, Philip, and Dana. You're all going to get Agoras this month. And don't forget to follow us on our socials. That's Tao_net on X or Twitter. That's TaoNet Agrs on Reddit. And that's TaoNet on Telegram. All right, see you soon. Cheers.